Algebra 1, Lesson 2, Integers. We briefly mentioned integers in the previous lesson about number sets, but let's go into them in more depth. We will start by once again defining what an integer is. Integers are the set of whole numbers and their negatives, including 0. Integers can be represented with a number line, where negative numbers are to the left of 0 and positive numbers are to the right of 0. 0 is considered a neutral number. Here is a picture of a standard number line with all the different sets and subsets of numbers pointed out. There are 4 basic operations that we can do with integers: addition, subtraction, multiplication, and division. As you may have learned in earlier math classes, addition and subtraction are inverses of each other, or they are operations that reverse or undo each other. Multiplication and division are inverses as well, but have different properties and special cases that we'll discuss soon. Addition and subtraction of integers are relatively straightforward operations. In your earlier math classes, you were most likely taught to use the number line to add and subtract whole numbers. With integers, we will be incorporating negative numbers with our operations, so we will need to learn how to use them correctly. First, you need to know what the absolute value of an integer is. The absolute value of an integer is the non-negative value of that integer, regardless of its sign. It is specified by 2 vertical bars around the integer. For example, the absolute value of -9 is written like this, which is equal to 9. When adding 2 integers with the same sign, we add their absolute values and attach the sign of the original numbers. For example, 10 plus 5 equals 15, and -11 plus -6 equals -17. When adding 2 integers with different signs, we subtract the smaller absolute value from the larger absolute value and attach the sign of the number with the larger absolute value. For example, 4 plus -8 equals -4, and -3 plus 5 equals 2. Subtraction works in a similar way, with the added step of changing the sign of the second number and then proceeding with addition. For example, 14 minus 12 equals 2, and 14 minus 12 equals 26. Moving on to multiplication and division. When multiplying 2 integers with the same sign, the answer, or what we call the product, is positive. When multiplying 2 integers with different signs, the product is negative. For example, 5 times 6 equals 30, and -5 times -6 equals 30, but -5 times 6 equals -30. Division follows the same rules with the signs as multiplication, but there are some special cases. Dividing 2 integers may give you a fraction a lot of the times instead of a whole number. Fractions have their own special rules when it comes to using the basic operations and applying them correctly to evaluate fractional expressions. We will dive deep into those rules in the next lesson. There are some special cases to consider for dividing with integers. 1. You cannot divide an integer by 0, as it is undefined 2. If you divide a positive integer by a number smaller than itself, you will get a fraction that represents a number between -1 and 0 and 0 and 1, not including 0 itself. 3. If you divide a positive integer by a number larger than itself, and the answer can't be represented as a whole number, then it is an improper fraction. 4. If you divide an integer by itself, the answer is always 1. In conclusion, the understanding of integers is very important, not only for this course, but for higher-level math, science, finance courses, and other similar educational endeavors. Now that we should have a basic understanding of how integers work, let's move on to another important set of numbers mentioned earlier called fractions. See you in the next lesson.